Very good evening to all. Very good evening to one and all. Thank you for joining. Today we are gonna see sequential circuits. Very good evening to Bharat Rosing. Welcome. Venkat, good evening. Narayana Murthy, very good evening. Joy Chaudhary, very good evening. Radhika Kumar, very good evening. Narayana Murthy, welcome back. Very good evening to one and all. Thank you for your joining. Today we are going to see the sequential circuits. So yesterday we seen combinational logics, combination circuits, and then yesterday also we seen basic intro about sequential circuits. So today we will see the brief explanation about sequential circuits. So thank you for your joining. Vaishnavi PV, very good evening. So Sri Krishna, very good evening. Electronics. So Vamsi Krishna, very good evening. So is my voice is clear? Can anyone respond in chat box? Is my voice is clear? And then my face is also visible for you. If it's clear means just put S in chat box. Is my voice is clear? If my voice is clear means just put S in chat box. Chandru, good evening. Abhishek Show, very good evening. Manoj, yeah, thank you. Thank you for your response. Vaishnavi, Radha Krishnan, and then Vamsi Krishna, and then Abhishek. So thank you for your response. So without delay, we will get into session. So today we are gonna see the sequential circuits. So yesterday also asked one questions how the ATMs are give the cash without with if you are correctly enter the correct pin number, then only it will give the cash. So the basic logic behind of this process is nothing but sequential circuit, sequential logic. So sequential logic is nothing but it will give the output based on the current input and also previous state, previous memory state. Okay, clear and visible. Thank you for your today's session. Okay, thank you for your response. Varlashmi, very good evening. So main thing is the basic definition of yesterday we seen this question also. So basic this is answer for that. If we were combinational logic, if you are using the combinational logic, the ATM won't remember that you were entered pin. Okay, though based on that it will not give your cash. So ATM must be store your pin, based on the pin only it will give your cash. So that's why sequential logic are using in ATM machines. So the basic definition of the sequential circuit is the output is depends on current input and also previous state output. So this is the basic definition and basic working of sequential logic, sequential circuits. Basically sequential circuits are like at resistors. So it means store. It's like a storage unit. So we can say it's like a memory unit also. So while entering into Verilog code, if you are writing if you are making the memory means why you can use rich keyword is like a register keyword. It's like a memory only. So basically sequential circuits also known as memory logic. Okay, it will store a single bit of data. For example, if you take like a D flip-flop, it will store the 1 bit of data up to 1 clock cycle. 1 clock cycle is nothing but one passage to another passage. So before entering that clock related things, I will ask one questions. So do you guys know about clock pulses? So what is the clock? So how it's look like this? How it will look like? So can you if you guys know means just put S in chat box. If you guys know the clock basics like a passage, decade, edge triggering, level triggering. So this is very basic need of VLSI engineer. If you guys know means just put S in chat box. We will see that in that also in the session. But before that, I will ask some. This is I want to know. Yeah, Naga. Okay, thank you. No, sir. Okay, no, don't worry. I will explain in this session. So what is a passage? What is a neckage? What is a level triggering? What is edge triggering? So what is how the clock cycle look like? So we will see in this session. So okay, some people are some people are not knowing. So don't worry, we will see in this session. So Basically, combinational circuits won't need the clock pulses, but in the sequential circuits, it will works based on the clock pulses only. It will work based on the clock postulates, or if you take as example flip flop or latches, it having some triggering element. Flip flop using the edge triggering, latches using the level triggering. So the triggering element will fully based on the clock pulses only, clock cycles or clock input. So we'll see one by one. So sequential circuits depends on both current input and the previous state stored in memory elements. So this is the main thing in sequential circuits. So sequential circuits are digital circuits that store and use the previous state information to determine their next state. Okay, next state is nothing but output. So these are basic definitions of sequential circuits. So this is a basic block diagram of sequential circuits. So here you can see here it having the combinational circuit and then memory element. So output is depends on previous state. So this is a output getting here combinational logic, and then the previous output are stored in memory, and then current output will depends on current input and also previous state output. So this is how sequential logic will work. So if you guys understand this block diagram means just put in X box, just put the S in chat box. So here there is a combinational circuit logic. Here it will determine the output. Okay, it will determine the output. How it will determine the output means it will determine based on the previous state output from the memory element. It will take the previous state output, and then based on the current input, external current input. External input is nothing but current inputs. Okay, so it is fully these combinational circuits determine the output based on the previous state which is stored in memory element and then current input. So based on these two input, it will determine some output. This is a working of sequential circuits. I hope this is clear for you guys. Yeah, yes, Pro Radha Krishnan, thank you for response. I hope this is clear for you. So and then we'll move into types. So in combination logic, we don't need it. We don't need any synchronous asynchronous. Why? Because of it's like a continuous assignment. So whatever given to that particular gate, it will perform and then it will give output. So there is no need for there is no need to determine synchronous asynchronous kind of things. Why? Because of it is a independent of clock. Okay, combination logic is independent of clock, so it will work without clock. But here sequential logic we are using clock. Okay, clock having the if you are working with clock means you can define the logic with the two types. One is synchronous, another one is asynchronous. So main difference of synchronous and asynchronous is nothing but synchronous means your logic. So for example, you are having the D flip flop, you are having the 5 D flip flops are connected with the sequentially, like a serially. You are connected the 5 D flip flops. So each and every flip flop are need clock inputs. Based on that only it will work. So each and every flip flop need clock inputs. Okay, assume that I will show the circuit later. So you have the 5 D flip flops. Okay, 1 2 3 5 D flip flop. Each and every D flip flop work based on the clock inputs only. If you given the clock input parallel means you having one clock input, you are connected with each and every D flip flop. So you are given like a separate clock input, but the main clock input, main source is one clock input. You are giving the clock input to each and every D flip flop means it is the synchronous sequential circuit. So asynchronous is nothing but it will operate the independently clock source, like a clock signal. It means you are connected the 5 D flip flop, and then you are giving the clock input for only the first D flip flop. Okay, and then the output of D flip flop is giving to second D flip flop clock input. So it's like a overlapping kind of things. So if you are following this method, is called as asynchronous sequential circuit. So if you are giving the one clock input to all D flip flop separately means it is a synchronous. You are giving one by one, like if you are giving if you are giving one clock input to each and every D flip flop separately means it is a synchronous. Okay, and then so asynchronous is nothing but you are giving the only one clock input for first D flip flop. The output of that particular first D flip flop will given to clock input as a clock input for second D flip-flop, and then the second output, the second D flip-flop output is will given as a clock input for third D flip-flop. If you are given like this overlapping method is a asynchronous sequential circuit. Okay, I think it's understand for you, so I will show the diagrams, circuit diagram, then only you can easily understandable. But basic thing is this is the difference between the asynchronous and then synchronous sequential circuit. So synchronous sequential circuits operate based on the clock signals. Okay, asynchronous sequential circuits operate independently of clock signals. So there is two types of circuit in sequential circuit: asynchronous and then asynchronous. Okay, so and then this is a clock responses. So how output will be clock frequency? How output will be on clock frequency? So Darshan, can you explain your question? So I'm not clear with your question. How output will be on clock frequency? So can you explain your question once again? So basically we are dealing with clock's response. So I already said no. We are having the two elements in sequence circuits. One is flip-flop, another one is latches. Both are capable to both are working with the clock pulses, and also both are capable to store the data. Data means bits, binary bits. Okay, it can store the single bit up to one clock cycle. So for that it needs some event triggering. So event triggering is nothing but the main thing is clock cycle having. So as you can see here, so this is one clock cycle. So from this passage, this is act as a passage. I will show you also here. So you can see here this is rising edge. From 0 to 1 is one rising edge, and also this is one rising edge. Here also 0 here. So a clock having a clock is mainly known as combination of zeros and ones. One off time, one load, one on off time. Sorry, on time. So off time is nothing but 0, on time is nothing but 1. So rising edge 0 to 1 and then 0 to 1. So this is a rising edge. You can see here that arrow mark. It is referring as rising edge. From one rising edge to another rising edge is called as clock cycle. This is one clock cycle. It having combination of high and low. So it is the combination of the time taken of this clock cycle, like a time taken of this clock cycle. So this is one clock cycle. One rising edge to another rising edge is called as one clock cycle. The time taken is depends on frequency of clock. So what you are giving frequency. For example, you are giving the 50 megahertz of you are using the 50 minutes of clock. So you are using 50 minutes of clock. The time taken for one clock cycle is 20 nanosecond. It means 10 nanosecond off time, 10 nanosecond on time. It may be a combination of on and off. So this is a passage. This is also passage. One passage to another passage is known as one clock cycle. Okay. Sir, how flip-flop will generate clock? So how flip-flop will not generate the clock. It will use the clock which is given by the crystal. So I already said no. While switch on your computer, while boot your computer, the main component is needed, like that is crystal. I asked this question, I think second day or first day also. I don't know, but I think second day. The main thing is clock. So clock is given by the crystal. So there are only one clock inputs for our chip. So chip need the clock pulses. Why? Because of we are using the sequential logic a lot. So we need the clock inputs which is given by the crystal. Crystal, there are many types. We can buy 50 megahertz of clock, say 50 megahertz of crystal, and also 25 megahertz of crystal. For example, I will show the Arduino. You can see here, this is a crystal that you can see, you can also see here. Yeah, so you can see here, this symbol, this is a crystal oscillator. This is a physical device, physical hardware, which is in our Arduino board. It will give the 16, you can see here T16. It means it will produce the 16 megahertz of clock frequencies. Okay, so this clock source will given to this main controller, main chip, main IC. So this is how flip-flop will getting the clock input from crystals. So it will connected by wire. Okay, so in this chip there is a one separate pin like a global clock pin. So it will receive the clock pulses from this crystal, and then that global pin in our chip, it will distribute the clock pulses, distribute the clock frequency overall the chip. So wherever we need the chip, wherever it need the frequency, means it will given by the global clock pin, which is in the main controller, main chip. So flip-flops won't create the clock, it will use the clock only based on our clock frequency which is given by the crystal. So then how asynchronous circuit will work without any, so I will show that also. So asynchronous circuits work with clock only, but we are giving clock input only for the first D flip-flop. So this is a difference. So for example, also the circuit. So you can see here, this is I already said no, this is one flip-flop, D flip-flop. I think it's visible for you. So I think it is visible for you. This is one flip-flop. This is I'm connected the 4 D flip-flop in serial. I'm giving like a clock input only for the first D flip-flop, and then it will give output. So the output of this D flip-flop I'm giving to input for the clock for my second D flip-flop. And also you can also see here the output of the second flip-flop will given as a clock input for my third D flip-flop. And also third flip-flop, output of third flip-flop will given as a clock input for my fourth D flip-flop. So this is how asynchronous circuit looks like. So this is how I'm telling, it will based on the clock only. So it is based on the clock only, but the clock will not given separately for all D flip-flop. So this is how the asynchronous circuit look like. So if I change into synchronous, it will look like this only. You can see here. So you can see here this is one clock input. I'm giving the clock input separately for all the D flip-flop. So it will go in here, and it will go in here, and it will go in here. So each and every D flip-flop having the separate inputs. It is not depend on previous D flip-flop output. So this is known as synchronous sequential logic. So the clock input is given separately for each and every D flip-flop. If you make like this circuit, means is known as synchronous. The particular D flip-flop is depend on the clock inputs depends on previous D flip-flop, means it is asynchronous. Okay, this is a difference between the asynchronous and synchronous. Synchronous will give the direct input, so will give the direct clock input for each and every D flip-flop. Asynchronous not like that, it will given by the previous D flip-flop output. Okay, I think it's clear for you. I like flip-flop circuit generator work. So the output of the first flip-flop is synchronous, will not be a clock frequency. Then how the second flip-flop work? So it's like it will work continuously. If you are giving input clock inputs for the D flip-flop, and then if you stop the input, if you stop the clock, if you are stopping like a, if while a clock, mainly clock is nothing but combination of zeros and ones, you are continuously giving clock input for your circuit. If you stop means the circuit won't work. If you didn't stop means it will change like a, how to say, so first it will work parallelly. So this all D flip-flop works parallelly. Okay, why? Because of the clock inputs giving separately. If you take an example like this, this is the asynchronous circuit. So you are giving clock input for this D flip-flop. It will based on the passage of, it will, the edge triggering is based on the passage. So one passage it will get the input. So whatever it having the value, it get the input. Here D is a input, and then it will store one clock cycle. So for example, D equal to 1, so it will store one clock cycle. In the second passage it will throw out the output. In the second passage, it means it will throw out the output in the Q. The Q output will given as a clock input for my second D flip-flop. So in the third clock pulse only, the particular D flip-flop will work. It will get the data from the it will work, it will perform. So that is a time taken. So we are continuously giving clock here. If you are giving clock means it will work. So if you want to access this D flip-flop means the particular D flip-flop, the second D flip-flop have to wait the at least 2 clock cycle to get the access, to get the functionalities. Why? Because of firstly that particular D flip-flop will receive the input, will store the input, and then will give the output. So after completion of this D flip-flop only, this D flip-flop will get the input from this one, and then it will work. So this is how the clock inputs are passing over the synchronous circuit. Can I know how can we differentiate the given synchronous or synchronous? So main thing is synchronous means we are giving the clock input separately to all the D flip-flops, to all the flip-flops. Here here you can see now we didn't give any direct input, clock input, when we didn't give any clock input separately for all the D flip-flops. Each and every these all things are called as D flip-flop only, but we are not giving the direct input, we are not giving the direct clock input for each and every D flip-flop. So each and every D flip-flop depends on previous D flip-flop output. Okay, the output of this D flip-flop is given as a clock input for my second D flip-flop. That this the second D flip-flop output is giving as a clock input for the third D flip-flop. The output of third flip-flop will giving as a clock input for my fourth D flip-flop. So this is how it works asynchronous circuits. So output will be feedbacked as a clock frequency rate. So not clock frequency. So we are getting out. So it is the if you're taken like this, like if you're taking the third flip-flop, so it will use the previous output to as a clock input. So maybe the D flip-flop will store only 1 bit. So it can't store 2 bit, 3 bit. It will store only 1 bit. So either 0 or 1. So each and every, we are continuously giving input like a 0 1 0 1 combination here, passage and a gauge. So based on our edge triggering, it will work. Okay, it's not based on the execution and then the data transferring of this across this D flip-flop is depends on frequency. If you are using the high frequency clock means you will get your circuit will work fast. Why? Because of F equal to T1 by T2 means frequency is inversely proportional to time. So if your frequency is high means your time is also your working time will be reduced. So frequency is inversely proportional to time. if you increase the time means you can reduce the if you increase the frequency means you can reduce the time, execution time. So I hope it's clear for you, and then let's move into remaining topics. So this is and then coming to the triggering. So each and every clock pulse is having the positive edge neckage. Okay, so this is a positive edge triggering, and then this is a negative edge triggering. This passage to this passage is 1 clock cycle, it having the off time and on time. So and then another thing is a level flip flops are using based on edge triggering. It may be passage, it may be negate, and latches are using the level triggering. So level triggering is nothing but this level, like a on time off time. So this is a level triggering. So it will work based on this level. So the flip flop will based on this edge only, but the latches will work based on the level of the signal. If it is I means it will transfer the data. I will show you one by one. So and then this is the response, clock response. We have positive edge, negate, and then positive level triggering. So latches are based on the level triggering, and then flip flops are based on the passage or negate edge triggering. So and then storage elements. So we can call as, we already know the flip flops and latches, or we can call as storage elements. Why? Because of storage element is digital circuit maintain the binary state indifferently. So storage element that operate with the signals levels rather than the transition of clock. So it will, so for example, if you take as a D flip flop, it will store 1 bit of data, but how long it will store? It is based on the triggering. So one passage to another passage. For one clock cycle, it will store. For single D flip flop, it will store 1 bit for one clock cycle. For example, you having the D flip flop, you are giving input like a clock input, like it will combination of zeros and ones. If the D flip flop finds a passage, so it will get the data, and then it will store one passage to another passage for one clock cycle. After that, for second passage, it will throw out an output. So one passage it will get the data, and for one clock cycle it will store, and then in another passage it will throw out the output. So this is how D flip flop work, and then based on this logic we have in the remaining D flip flops like J flip flop, SR flip flop. So these all things work based on like this D flip flop only. And then we having the T flip flop, toggle flip flop. So we'll see one by one. So can you send the study materials for your reference, sir? Okay, I will share. So VLSI uses level triggering. So it is a nature. So it's a nature only. So the clock having the two triggering elements. One is edge, one is level triggering. So we are assuming like that only. I think for my understanding, it's just a name kind of thing. So edge triggering means flip flop, level triggering means latches. So I'm not clear about that. Why we are calling the latches triggering? Why latches uses level triggering? So I will tell you tomorrow with this answer. So I already said flip flops are edge sensitive. Latches are said to be a level sensitive devices. So and then this is a basic D-latch. So D-latch having on another signal is called control signals. If the control signal is high means it will work. So it will work based on the control signals. So this is a circuit of D-latch construction. So and then so if it is, so I already said no, D-latch, D flip flop are capable to store 1 bit of data for one clock cycle. So this is how input is T is input 0, output is Q 0, and then input is 1, output is also 1. So this is how D-latch are created. So inside that it having the basic S bar R bar latch. So I'll show this S bar R bar latch to table in upcoming slides. So and then latches in feedback loop. So this is one example. So why latches are very bad. So while writing the sequential logic, we mostly have to choose sequence like a flip flop logic only. Why? Because of flip flop is edge triggering, so latches is level triggering. So if you are using latches means you will get some race around condition. So race condition is nothing but I will ask questions. So if you guys know the race condition, means what is a race condition? Race around condition in sequential circuit. So what is a race around condition in digital electronics? If you guys know means just put in S in chat box. So what is control signal? So control signal is like control name itself, it having control signals. So if it is high means it will work, if it is low means the circuit won't work. So what is the main difference between the D flip-flop, D and F flip-flop? Yeah. So race condition is nothing but you having one variable like a, at the same time we are assigning a equal 5, a equal to 10. We are assigning same value like a different value for particular one variable. So we are assigning the same time. So the simulation tool won't know what value we have to assign. So this is the race conditions. So that particular signal will changing continuously at the same time. It may we are assigning 0 and 1 at the same time for the particular signal is nothing but race bound conditions. Continuous toggling, yeah, correctly, Sri Satya, you are telling correctly. Yeah, S equal to 1, R equal to 1 is SR flip-flop. So continuous toggling of flip-flop, it's a correct answer. So you are for particular flip-flop you are assigning the continuous input without with one passage. In single passage, so flip-flops are only based around the passage only. If it for example you are using the D flip-flop, you are giving input for D flip-flop like a 1. So 1 is a input for D flip-flop. It will fetch the input at the passage, and in the single passage you are also continuously giving input for D flip-flop. You already given like a 1, and then at the same time you are giving 0. So the D flip-flop will be in the confusion state. Okay, so it won't know which data I can take. So this is a race bound condition. So if you are using the latches in your logic, in your sequential circuit, means you maybe receive the race conditions. That's why we have to use always flip-flop circuits. So this is how it works like. So latches, here we are having the one latch device, another latch device, then is a combination logic. So combination logic will continuously give the output. So it is input for this latch, and then but this latch is level triggering. So it will store up to one high, so clock high level triggering. After that only it will send to the next one. Okay, in this next one. So sorry, but the combination logic will receive the input continuously. Here is having 1 0. So but actually we need one, we need to have 1 here, but we are having 0. Why? Because of it will take some level triggering time, so it can't change here. So actually we need 1 here, but we are having 0. Why? Because of this latch will take some time to give the input for this latch. Okay, so at that time this latch will give the output as a 0, but we need 1 as a output from this latch, but it is giving a 0 output from this latch. So I am giving into the conventional circuit. So definitely I will get the wrong data, or else I will get the junk values. So that this is how latches are very bad while writing the sequential logic. It will take more time to give the output, and then there is a chance to getting the race conditions. Okay, so and then this is the S bar or R bar latch with the NAND gates. So and then we'll show you the another thing. This is a simple thing. I think it's so based on the C is this is the SR latch with enable or control signal. So the C is a control signals. Set S means set, R means reset. So it having the 2 inputs, like a 3 input set, reset, and then control signal C. If the it's a control signal is nothing but it's like a clock only. So if it is C equal to 1, like a control signal is having 1 means, then only it will execute it will perform the SR latch, okay, functionalities. Otherwise it won't perform. If the C equal to 1 means it will execute the SR latch functionalities. So you can also see the truth table when these are the truth table for the circuit. So when clock, like a control signal is 0, so it won't execute, so it will take unknown value. Then Q, the output is also no change. Whatever it having previously, it will giving that only. And then if the input is like a clock in control input is 1, and then S and R set and reset having the 0 0 means you will receive the output no change, whatever already we receiving, you will getting the same output. And then if the control signal is high and then set equal to 0, reset equal to 1, it means you will get the, so here reset is high, so it means you will receive the Q equal to 0 0 as a output from this circuit SR latch. And then if the S set equal to 1, reset equal 0, it means you will get the 1 as a output. If both inputs are 1 1 means you will get the intermediate output, it may be 0 or 1. Yeah, yes, usually race around condition appeared in level clock flip-flop. Yeah, thank you for response, Sri Satya. It's you were getting clearly. So this is how SR latches work. Okay. So this is output waveform of SR latches. So the based on the control signal it will work. If set is 0, you will get the output as 0. If set is 1, you will get the output as 1. Okay. So and then D-latch, transparent latch. So this is a basic functionalities of D-latch. So whatever giving to D-latch, you will get the same thing. You can see here 0 is input, 0 is my input, and then 0 is my output. 1 is input, same 1 is my output. So this is how D-latch works. This is a circuit for that. So and then problems with latches. That's I am telling race around condition is the main thing. This is thing I explained here in these points. So we'll move into the graphical symbols of latches. SR latches, and then SR latch active low. So active low is nothing but if you given like a bubble over here, it means SR latch with the active low, so active low logic. So and then D latch active high. So this is how graphical symbol of latches. Okay. So and then what is called transparent latch and D type. So transparent latch is nothing but it is just reflecting of a D latch with the basic logic circuit of SR, like a S bar, like a S bar R bar latch circuit. This is how transparent latch working. So I think this is for latches. So latches main thing is we mostly need to avoid the using latch logic in our sequential circuit. We mostly have to use flip-flops, and then latches work based on the level sensitive, level triggering. The based on the control signal only it will execute. So this is the latches. So before going to the flip-flop, I will share something about internship. So if you guys are really interested in this 30-day masterclass, you can convert this masterclass into 1 month internship program, internship on VLSI advanced VLSI design and verification. So this is the benefits. You already know that you will get all the details, recording session, all the details, PPTs, and then source codes, downloadables, and then you will get the exclusive projects, 4+ projects, and then you will get the IETE confirmation letter, and then you will get the 180 days LMS course access. This is the main things. I think you will get up to 6 month access of recorded videos. So and then we are providing the weekly live sessions for 1 month, and then we are giving some tasks, so it will helpful for you. And then you will get the academic internship report. So if you are a college student, if you are looking for internship means, it will helpful for you, so you can easily use the report for your submission of report. So and then you will get the high valued IETE certified internship, like a IETE certified internship certificate from the IETE. So these are the benefits you will get in the internship program. This is our fee. You are getting all these 8 benefits at the discounted fee of just 999. Our regular fee is 499. So in this masterclass period you will get this offer. So by using this registration link, and also you will get the link in chat box, by using that you can purchase our internship program. So after that, clicking the link, you will receive this window. So here in the domain you have to choose advanced VLSI design and verification. Then only you will get my internship program. there are a lot of programs in the domain. You have to choose this advanced VLSI design and verification. Okay, so and then you will get the certificate like this only. This is sample certificate of the internship program from the IETE. It's like a central government institute, and then this is the things. So from the internship benefits. So if you guys are really interested, you can get this internship by using this link. Okay, so and then we'll move to the flip-flop. So Natarajan, good evening. Naveen Radhe, why it's called transplant latch D-type? So good evening, kindly post that. So you will get the link in chat box, or RS will post the link. And then Chaudhary. So Abhishek show is there PPU. PPU means, so Jax, good evening Natarajan. So let's get into flip-flops. Flip-flops work based on the we already said that it is a level, it's a edge triggering. It will use the edge triggering to fetch and give the output, to fetch the input and give the output. And then it may be positive edge, it may be negative edge. So this is a flip-flops work like positive edge, negative edge triggering. Okay, so this is example of positive edge triggering D flip-flop. So here I am giving the input directly. So for one, if this clock signal, let's say clock input, it is always looking for positive edge. If it is positive edge occurrence, means it will get the data from the signal, and then it will store one passage to another. Sorry, it will store one passage to another passage. In the second passage, it will throw an output. So this is it will store only one bit of data for one clock cycle. So D is this is the input D, 0 is my input, and also my output is also 0, and then 1 is my input, and my output is also 1. This is how D flip-flop working with the positive edge. So you can see here 0 to 1. This 0 to 1 transition is very important. So and more thing, I will ask on another question. How many people are aware of the setup time, hold time? Okay, can you anyone respond in chat box? How many people are aware of setup time, hold time? So why? Because of we are dealing with the edges, positive edge, negative edges. So there is something like a setup time, hold time in clock. So can anyone respond in chat box? Yeah, pre-placement offer. So we are providing some assistance for placements, like only for assistance. We are not guaranteed to give the placement, so we are giving the assistance for placements. I think it's I understand for you, Abhishek show. So that's why D flip-flop is called D flip-flop, data flip-flop, or relay flip-flop. Yeah, you are telling correctly normally. So my question is, how many guys are aware of the how many guys are know setup time, hold time in clock? Setup time, hold time. If you guys are aware of that, if you guys are know, means just put S in chat box. So Narayana Murthy were telling us, very good, it's nice, it's clear, it's very nice to see, just see your response. So remaining people, just setup time, hold time. So setup time, hold time, I will tell you that also. So I will check here. So setup time and hold time. So there are two timing in the clocks, setup time, hold time. So this is that. I think it's visible for you. So here this is one. If you are following the positive edge triggering, okay, so this is one positive edge. So before the before the positive edge, sometime you can see here setup time. So 0 here, and then it is there's a transition of 0 to 1. So this is a positive edge. So sometime before the positive edge, if this time is called as setup time. After the positive edge, sometime is called as hold time. So for example, I am assigning a variable. If while writing the Verilog code, I assume that I'm assigning I'm using one signal, input signal A. I'm assigning I'm assigning value for the signal A equal to 5, A equal to 0, A equal 0. So that 0 value must be stable in setup time and also must be stable in hold time. If it is not stable in from this setup time hold time, means it will cause the metastability, it will cause the timing violation. Why? Because of while in the passage it must be stable, so in the setup time it must be stable. After the passage also that signal must be stable. If it is any changes happens in setup time and hold time, means it will give the violation, timing violation, or else it will give the metastability. So metastability is nothing but it may be 0 or 1. If any unstable happens in occurs in setup time hold time, means you will get the metastability state. It may be 0 or 1. Rise time, fall time, yeah. So rise time, fall time, not like a setup time hold time. This is a setup time hold time is the correctly. So there is a one rising edge. So before the rising edge of some time and then after the rising edge of some time, we have to that particular signal must be in the stable, must be in the state, must be in like a stable only. If it is in the unstable, means that state it will give the violations, timing. You will receive the timing violations, and also you will receive the metastability state. So this is the main thing while dealing with flip-flops. We have to aware of that. So for that while writing the Verilog code, design code, you will receive some metastability state, and that time there is a lot of techniques to rectify these timing issues, like a double registers, lot of things there. So we will see in upcoming classes. So are you guys understand the setup time hold time working? If you guys are understand, means just put S in chat box. If you guys understand the like a setup time hold time functionalities, timing violations, just put S in chat box. If you guys are understand, just put S in chat box of setup time hold time. So and then I will move to the level and edge triggering of flip-flops. This is a level triggering. I already know that this is a positive edge, this is a negative edge triggering of D flip-flop. Many electrical hacks. So setup time hold time is nothing but, so assume like if you are already written some Verilog code, means it will easily understand for you. So for example, if you take one example of D flip-flop, so D flip-flop is working based on the positive edge triggering. Okay, if one passage occur, means it will receive I'm storing the 0 into D flip-flop. So I'm giving like a here I'm giving like a 0 as input for D flip-flop. Okay, so in the passage the D signal must be before the passage, before the this from 0 to 1 transition is there, it will take some time. Before the passage it will stable, and then it will receive the 0 value, and then after the passage also it must be stable. The D signal must be stable, will receive in the signals. So in the passage of D flip-flop, the particular signal must be stable. So if for example, if you're taking like a D as a signal for D flip-flop, it's input signal. The input signal must be stable in setup time and hold time. If it is any unstable occurs in this, means you will get the metastability state. So till I think it's hope I'm clear, it's understand for you. So the main thing is we have to stable in the particular signal must be in the stable state of setup time and hold time. Then only you will get the correct results, otherwise you will get the unwanted metastability result. So metastability is nothing but it may be 0 or 1, so we can't determine that, so you will get the unknown values. So this is how it works. I think it's clear for you. If you guys really understand this metastability, like setup time hold time, just put in S box, just put S in chat box. And then we'll see remaining topics. There are a lot of topics here. So and then so other flip-flop with D flip-flops. So D flip-flop is simplest flip-flop that can be built with less number of logic gates. So this is a basic information about D flip-flop. So I think it's clear for you. Setup time, hold time. So while writing the Verilog code, it will understand for you. So why? Because of I will tell you in the while writing the Verilog code, SystemVerilog design code. While entering into design code, while if you are seeing the practical output means you will easily understand. The main thing is setup time, hold time. You must know there is a setup time, hold time. We have to stable the signal on setup time, hold time. It is the main thing you have to take in your mind. Okay. So Muhammad Tawfiq, can you explain 1 second, sir? So main thing is D flip-flop. So this is a D flip-flop. This is a D flip-flop. We are having the D flip-flop. This is the input for D flip-flop. We can give 0 or 1 from this signal. So this work based on the clock inputs. So this clock signal will always looking for positive edge. I assume like this is work based on the positive edge triggering. Okay, this clock signal will always looking for positive edge, like a pass edge. If it is a pass edge occurs means that it can receive the data from the signal D. Okay, we can give the data from the from this input. Okay, we can give an into data for this D flip-flop. Okay, at only stage of passage is occurring means, if it is not occurring means we can give. So in the passage occur means we can give the data for D flip-flop from this signal. Okay, so at the passage occurring means, so D flip-flop will get the data from input. So assume like D equals 0. So the D equals 0 value must be stable here, setup time also, and then here also. There is a two time in the clock pulse. Sometime before the passage and then sometime after the passage is called setup time, hold time. So setup time means before the passage the signal must be stable, and then like this time. So and then hold time means after the passage the signal must be stable. So stable is nothing but we are assigning D equals 0 for D flip-flop. Input D equals 0 means the D equals 0 must be stable here and also over here. This is the, if it is any changes, if it is any happening of unstable things means you will get an unpredictable data, so unpredictable outputs. So I think I hope clear for you. So the main thing is that if you are assigning some values for some signal, so D equal 5, A equal 5, B equal 5, so that particular all the signals are work based on the positive edge triggering means that signals must be stable in setup time and also stable in hold time. Then only you will get the correct output. If any unstable, if any changes means, while assume like here A equals 0 and then here A equal to 1. So there is a changing of signal values. Here 0, here 1 means in the setup time A having 0, in the whole time A having 1. So there is a changes. So you will get the unpredictable data only. Why? Because of my input is A equals 0 only, but it is changed here A equal to 1. So it is not my data, it is changed unknownly. So that's why we will get the metastability state. This is how it work. Yeah, okay, thank you for response, Tawfiq. So we'll see the remaining topics. So this is how it works already. So this is the other types of we having other types of flip-flops like a JK flip-flop, T flip-flop. T flip-flop is nothing but toggle flip-flop. JK flip-flop is also work based on the SR latches. So and then in the typical integrated chips has millions of logic gates and flip-flops inside them. Okay, so and then clock pulse transition, we already know that 0 to 1 positive pulse, 1 to 0 negative pulse. So master slave D flip-flop. When clock changes to low, the master is disabled after having the store the state of D into it. It means, so it will work based on the passage. So one passage means here I'm using enable signal. I'm storing 1 bit of data, and then a master. This is a master D-latch, and then the output of master is given to my slave D-latch. This is how it works. So it will slightly difficult to understand. So I skip this. So on the flip-flop, I already shown that how it's working. It will store the 1 bit of data for one clock cycle. It is based on the passage or neckage. If a passage occurs, means it will receive the data, and then it will store up to one passage to another passage. It means one clock cycle, and then another passage it will throw the output. This is how flip-flops works. Basically, it will store the data for one clock cycle. Okay. So and then JK flip-flop. So JK flip-flop is nothing but like it's work based on the SR latch itself. If S equal to 0 means you will get the Q as output 0. Same like if S equal to 1 means you will get the output Q is 1. So this is circuit look like. So here, so JK, so J and K input are 0 0 means there is no change memory state. If J input are 1 and then K is 1, so sorry, K having 1, J having 0 means you will get the zeros output. Like it's like a R, sorry, S and R. So if J equals 0 means you will receive the output as 0. So it's a work based on the SR latch. So set equals 0 means you will receive the output also 0. If set is 1 means you will receive the output as 1. So same like J equals 0 means you will receive the J equal to 0, output is 0. If J equal to 1 means the output is also 1. So 0 output is also 0, 1 output is also 1. It's like a set reset kind of thing. So and then if it is both J and K, it is both J and K is 1 means the output will be complement. Complement means Q bar. This is how it works. This is a circuit for the JK flip-flop. So this is a circuit for, this is the input circuit. So if you are giving, so for example here I am giving the input like a JK is a 0 1, okay, and then here I am giving like a not, I'm using NOT gate. So 1 works, 0 comes here, and then it will that this AND gate, it depends on this T flip-flop output. Already we having 1, so 1 comes over here. So 1 and 0 is 0, and then here also 0 and 0. So it will get the output from this Q for this AND gate. 0 and 0 0, 0 or 0 will get the output as 0. So R means addition operation, AND means multiplication. So and then D flip-flop, if you are giving a 0 0 for D flip-flop means it will store one cycle, and then it will give the output as 0. So from for one clock cycle it will store, and then another passage it will throw an output. So you will get the output as 0 from Q, and then Q bar is a complement of Q. This is how it works. Do we have any other flip-flops beyond SR, JK, T flip-flop? No, I think no. Neka, Kapil, so I did. I think I no. Thanks for nice session. So and then this is input combinations of J equal to 1, J equal to 1, K equal 0. If you are observing this means easily understand. So and then here set equal to 1, so reset, sorry, J equal to 1, K equal 0, you will get the 1 as the output. So this is how flip-flops works. So this is for today. So and then I think while writing the Verilog code, design code for this flip-flop and latches and then combination circuits, it will quite understand for you. So I hope this session is understandable for you. The main thing is setup time, hold time. If you want to become a VLS engineer, if you start your career with VLS engineer means you have to aware of the setup time, hold time. So what is setup time, what is hold time, and also please refer to your fade time, these clock related things, setup time, hold time, attachability kind of things. So and then if you guys are really interested in this masterclass, you can convert into 1 month of internship program, internship on advanced VLSI design and verification. So you will get these benefits, all these 88 benefits. You will get all 30 days recording sessions, all PPTs, source codes, and you can also downloadable, and you will get the 4+ projects, and then you will get the confirmation letter from IETE, it's a Central Government Institute, and then you will get the 180 6 months of LMS course access, and then you will get the assignment and task, and you will get the academic internship report. So if it is very useful for you if you are studying a college student, if you are studying in college. So and then you will get the IETE certificate, okay, internship certificate. So these are the benefits you will get at the discounted fee of just 999 by using this link, and also you will get the link in chat box. You can buy our internship program. So and then if you are given, and after that after clicking your internship link, like a registration link, you will see this window, and in the domain set form you have to choose advanced citizen verification, then only you will get our internship program. So this is a certificate you will get at the end of the internship program, sample certificate here. So thank you for listening. So if you guys are really interested, you can ask doubt. If you do any doubt, guys, you can ask now. Thank you, nice session. Thank you, sir. Thank you, Narayanamurthy. Thank you, Siddharth. So and also please read something about setup time, hold time. There are a lot of things in setup time, hold time, and the topic is called static time analysis. It is very useful for you while dealing with the flip-flops and the clocks. Static time analysis. So there are a lot of topics we have to read in VLSI while writing the design code. Okay, thank you guys. Thank you for listening. We'll see tomorrow. So tomorrow we'll see the overview of Verilog. We will write some Verilog code for flip-flops, control, and the combination circuits, and also we will see the introduction about SystemVerilog. So this masterclass fully depends on there are first 5 days only for theory part. After that 6th day, 7th day, we will get into coding part of SystemVerilog, basic OOPS concept, data types of SystemVerilog, verification environment, SystemVerilog architecture, kind of it is fully based on the verification. Okay. So thank you, Kapil. Thank you guys. Thank you for listening. We'll see tomorrow. Good night.